Section 1. Water, water everywhere. But what shape is it really? Alright, science enthusiasts, gather around. Today we're diving into a topic that's, well, everywhere. I'm talking about water. You see it, you drink it, you splash in it. But have you ever stopped to wonder about its true shape? Does it even have one? That's a fantastic question, and science has the answers. Water is a master of disguise, a real shapeshifter in the world of molecules. It can be hard as a rock, or it can float away like a cloud. So let's get to the bottom of this watery wonder, shall we? Consider this your backstage pass to the amazing world of H2O. When you pour water into a glass, it takes the shape of the glass, right? But what if you pour it into a boot? Yep, it takes the shape of the boot. Silly, I know, but it tells us something important. Liquid water doesn't have a fixed shape of its own. It's a conformist. It just goes with the flow, literally. But is that the whole story? Not by a long shot, my friends. There's so much more to water than just its liquid form. We're going on an adventure to explore its different states. Fasten your seatbelts because this is going to be cool. Section 2. The solid story. Ice, ice, baby. First up, let's talk about water in its solid state. You know it, you love it on a hot day. It's ice. That's right, ice is just water that's gotten really, really cold. Think about ice cubes in your drink, or a frozen pond in winter. That's solid water, folks. When water gets cold enough, specifically below 0 degrees Celsius or 32 degrees Fahrenheit, it changes. It stops being runny and becomes hard. It holds its own shape. You can pick up an ice cube, can't you? That's because it's a solid. Pretty cool, huh? Or should I say, pretty cold. So, what are those water molecules doing when they turn into ice? Well, they slow down. Way down. Imagine a dance floor where everyone suddenly starts moving in slow motion and then freezes in place, holding hands with their neighbors. That's kind of like what water molecules do. They arrange themselves in a neat, orderly pattern, a crystal structure. This structure is what makes ice solid and gives it its shape. They're still jiggling a little bit, like they're shivering, but they're mostly stuck in their spots. They form a strong, rigid lattice. Section 3. Liquid gold. The flowing form of water. Now let's warm things up a bit and talk about liquid water. This is the water we're most familiar with. It's the water in our taps, in rivers, lakes, and oceans. It's the stuff we drink to stay alive. Liquid water is fantastic because it flows. It can take the shape of any container you put it in, from a tall, skinny vase to a wide, shallow puddle. It doesn't have a fixed shape of its own, remember? It's a go-with-the-flow kind of substance. This property makes it incredibly useful for, well, just about everything in our lives and in nature. What are the water molecules up to in liquid water? They're more energetic than in ice. Imagine that dance floor again. Now people are moving around, sliding past each other, bumping into friends, but still staying pretty close together. That's liquid water molecules for you. They are close enough to be attracted to each other, which is why water sticks together in drops. But they have enough energy to move around freely, breaking old connections and forming new ones constantly. They're not locked into a rigid pattern like in ice. They're more like a friendly, bustling crowd. This allows them to flow and adapt. We use liquid water every single second of every single day. Section 4. Up, up, and away. Water is a gas. Alright team, let's turn up the heat even more. What happens when water gets really hot? It turns into a gas. We call this water vapor or steam. You've seen steam rising from a boiling kettle, right? Or maybe you've noticed your breath on a very cold day. That's water vapor from your lungs condensing in the cool air. Water as a gas is invisible unless it starts to cool down and condense into tiny water droplets like clouds or fog. It's water that is decided to take to the skies. It's much lighter than air when it's hot. So, what are our water molecules doing now in their gassy state? They're having a wild party. Imagine that dance floor again. Now, everyone has had way too much sugary soda, and they're bouncing off the walls, the ceiling, everywhere. They have so much energy they can't stay close together anymore. They break free from each other and spread out to fill whatever space they're in. That's water vapor molecules. They are far apart, moving super fast, and zipping around independently. There are very weak forces between them now. They are truly free spirits in this state. Section 5. The Great Molecular Shuffle. How water changes its outfit. Water can be a solid, ice, a liquid, or a gas, steam. It changes states with heat energy. Adding heat makes molecules move faster. Removing heat slows them down. Think of it like a volume knob. Turn it up, they dance. Turn it down, they freeze. This is melting. Ice absorbs heat and melts. The opposite is freezing. Remove heat and water freezes. Heat water and it evaporates. Molecules escape as vapor. Section 6. Water's wild side. A truly unique substance. Water isn't just any old liquid, solid, or gas, it's special. It has some really weird and wonderful properties that make it unique and essential for life. We already talked about ice floats. That's super unusual. Most things shrink and get denser when they freeze, but water expands. This is because when water molecules arrange themselves into ice crystals, they form a structure that has more empty space in it compared to when they're jumbled together as a liquid. This lower density is why icebergs float and lakes freeze from the top down, protecting aquatic life below. Another amazing thing about water is its ability to absorb a lot of heat without its temperature rising too much. This is called a high specific heat capacity. Think about the beach on a hot summer day. The sand gets scorching hot, right? But the ocean water stays relatively cool. That's because water can soak up a lot of the sun's energy without getting super hot itself. Section 7. Stay curious, keep learning, and hit subscribe. So, what is the true shape of water? As we've discovered, it doesn't have just one. It can be a rigid solid like ice, a flowing liquid that takes the shape of its container, or an invisible gas like steam. It all depends on how much energy its tiny molecules have. Water is constantly changing, moving, and shaping our world. When they're cold, they huddle together. That's ice. Give them some energy, and they start to flow. That's liquid water. Give them more energy, and they break free. That's water vapor. These transformations drive our planet's weather and life. The world is full of wonders like water, just waiting to be explored.